Okay, so we are starting a new topic, which is solving trigonometric equations, and on the screen you can see I already have prepared a little bit of it. And trigonometric equations are to do with our three trig graphs and solving these. So we have our sine graph, which goes from 0 up to 1, back to 0, down and back. And the important information is, for this one, our maximum is 1, our minimum is -1. And then we have 90, 180, 270 and 360 degrees. Okay, so those are all our angles. Okay, our cos graph, very similar, goes from 1 to -1. And we've got 90, 180, 270 and 360. And our tan graph, we've got our 90, our 180, our 270 and our 360, but we don't have any maximums or minimums for this one, but we do have asymptotes at 90 and 270. Right, so where do these graphs come in for helping us to solve trigonometric equations? This is because when we are solving, say we get that sine x is equal to 0.2, we can take from our graph, we can go, well, 0.2 is about here. We can draw a line. And that means that we have 2 points where we have an intersection of those two, the line and the graph. So we have 2 different points on our graph between 0 and 360 where it's equal to 0.2. But if we kept going with our graph, we get another one, and then we get another one, and even if we went backwards with our graph, we keep getting more. So we need a way of being able to find all of the solutions and not just one. And the thing that we do that helps us for this is we use a little table. I don't know why I drew an arrow, I was drawing axes for a minute there. Okay, so this is a visual representation to help us figure out where our answers are and how many answers there are. So we, on our little table thing, we look at it like it's a circle, and the start of our circle is over to where the x-axis would be. So we get 0 degrees, we get 90 degrees, we get 180 degrees, and we get 270 degrees, and then we get back round to 360. Because it's repeated, it's the same for each quarter or quadrant, like for every repeat or every, like if we go backwards for all of those as well, it's the same. So if we look between 0 and 90 for our sine, so we're going to look at sine, cos and tan in each of them. So sine in our first quadrant is positive. Okay, cos is positive. And our tan is also positive. In that first bit, if we look, all our values on that graph are positive in that first quarter here. So the first quarter, all our graphs are in the positive. Okay, so then between 90 degrees and 180 degrees, doing the same, we have sine, we have cos, and we've got tan. Okay, so sine is positive. Cos, though, between those two is in the negative part. So cos is negative, and tan is negative as well, because it's below the x-axis. We look through from 180 to 270. We have sine, cos, and tan. Okay, so our sine is now negative. Cos is still negative, but our tan is positive. And then on our last one, we've got sine is negative, cos is positive, and tan is negative. Right, so how does this actually help us? This is, once we find our solutions, there's things we can do. It's to do with the unit circle, and I'll show that in a second. But this is going to help us for our solutions, because when we get here, sine x equals 0.2, we can tell we're going to get answers from there. Where if sine is positive, we're going to get an answer there. So this is telling us that we've got sine is positive, so we're going to have an answer between 0 and 90. And because sine is positive there, we're going to have an answer between 90 and 180. But because sine is negative in the other two, they're quadrants where we're not going to get answers for this. Right? But writing out this whole sine, cos, positives everywhere, every time we do one of these questions, is going to be a bit of a waste of time. Okay, so the thing that we do is we create a little table, and we have A, S, T, and C. Where does this come from? This is just telling you what is positive. And A stands for all, S stands for sine, T stands for tan, and C stands for cos. So it's telling you which one's positive, and that is also telling you that the other ones must be negative. So in our second quadrant, sine is positive, but the other two are negative. In our third quadrant, tan is positive, but the other two are negative. In our third quadrant, cos is positive, but the other two are negative. And in our first quadrant, which all of them are positive. Okay, so ASTC, ways that people remember it, there's lots. People can call it a cast diagram. I don't think that really makes very much sense because we don't start with the C, we start at the A. So a way that works, and it's coincidental because of my name, which is Amanda Says Trig's Cool, as a way to remember, as my name is Amanda. But it's corny, I know, but if it helps you remember, then it's worth it. Okay, so we've got our cast diagram, which I'm going to just put up in the corner, the ASTC. And this helps us to solve our trig equations, and we should be using this every time we solve a trig equation. So trig equations we're going to get are going to be, for example, 4 tan x degrees minus 3 equals 0. I'm going to solve that between 0 and 360 degrees. Okay, so we take our question, 4 tan x minus 3 equals 0, and we're trying to solve, so we need to rearrange. So we add our 3 to both sides, so we're going to get 4 tan x is equal to 3. Divide by 4 to get tan x is equal to 3/4. Okay, so once we get to this point, this is where our cast diagrams comes in, and this is all in National 5, so it shouldn't be new, but I just did that as a wee reminder, and because sometimes people don't understand where the cast diagram comes from. So our tan is equal to 3/4, so it's positive, so that means it's in those two quadrants, the A quadrant and the T one, where tan is positive. Okay, so that means we're going to have two answers between 0 and 360. So the way that we do this is we look for our relative acute angle, and that's the angle that we would get in our first quadrant with a little triangle. So if we go back to trigonometry that we were doing before National 5, trigonometry that was just with triangles, not before we got to waves and things, we would find it with a triangle. So that's what we're doing here. Okay, so relative acute angle is going to be tan, the inverse tan of 3/4, and for the relative acute angle you're always putting in the positive into your calculator. It doesn't matter what you're doing, it's always the positive of it. So when we do that, we're going to get 36.9 when we round. So 36.9 degrees. Right, so the thing to remember is from this point on we've got to remember how we calculate that angle in each quadrant. So then x equals, the first quadrant is just your relative acute angle. Okay, but your third quadrant is going to be 180 plus your relative acute angle. Okay, because the second quadrant, it's starting to repeat, so it's the same size from 180 as it is from 0, so you have to add that 180 to it. which gives us our two answers of 36.9 degrees and 216.9 degrees. Right, I'm going to do one other quick example. This video has been a bit long and I apologise for that, but I'll do one more just in case with a negative. Okay, so we are going to solve 2 sine p plus 1 equals 0. And this one, actually, we're going to solve between and 720 this time, could in fact be a non-calculator question, and we'll see why in a minute. So we get 2 sine p plus 1 equals 0. So we take away the 1 to get 2 sine p equals minus 1, and then we get sine of p equals minus a half. Okay, so with our Amanda says Trig's cool or our cast diagram, we've got a negative, so that means it's going to be in these two where it's not positive. Okay, and then our relative acute angle is going to be the inverse sine of a half, because remember we always put the positive in there. So when we come to this, a half is in one of our special triangles, right? We always need to remember these. So it's 60 degrees and it is 30 degrees. So the sine is opposite over a hypotenuse, so opposite over hypotenuse, giving us that our angle is 30 degrees. Okay, that's our relative acute angle, so for P it's going to be equal to 180 plus 30. For our first one, it's going to be 360 take away 30 for our second one. And then it's going to be 180 plus 360, because we're adding an extra one. So it's going to be 540 plus 30, because that's when we come back round. So when we've done one full circle round, we get to 360. And then we're going back to here, which is 540. And then when we keep going for the next one, it's going to get to 720, take away 30. Okay, so we get our 4 answers, which are 210 degrees, we get 330 degrees, we get 570 degrees, and we get 690 degrees. Okay? So that is solving basic trigonometric equations. Okay, so if you've got any questions, let me know. If you want some more examples, if there's anything in this that you're unsure of, leave a comment and I can explain it for you. Please keep watching the videos, watch more. Let me know if there's anything else you want me to cover. Like, comment and subscribe.